Imagine looking at a map of the world. The familiar shapes of continents, the blue ocean separating them, all seem so permanent, as if they've always been this way. But what if the world you see is just a snapshot in a much bigger story? The continents seem fixed, but what if they're not? What if, beneath our feet, the ground itself is slowly, almost imperceptibly, on the move? This is the story of Alfred Wegener, a German meteorologist who saw the world differently. He wasn't content with the obvious answers, and he dared to ask questions no one else thought to ask. While others studied rocks in their backyards, Wegener saw a planetary puzzle. He noticed how the coastlines of continents like South America and Africa seemed to fit together, almost like pieces of a giant jigsaw. He proposed a radical idea: continental drift. The continents, he argued, were not anchored in place, but drifting slowly across the surface of the Earth. He suggested that millions of years ago all continents were joined as one supercontinent, which he called Pangaea. Over vast stretches of time, this landmass broke apart. Over time, this landmass broke apart, and its pieces have been drifting ever since. The world we know today is just one frame in this ongoing journey. Wegener wasn't a geologist, but his outsider's perspective let him connect dots others missed. He saw patterns in fossils, rocks, and even ancient climates that hinted at a shared past. He gathered evidence from geology, biology, and climatology, weaving them into a compelling narrative. Fossils of the same species found on distant continents, matching rock layers, and traces of ancient glaciers all pointed to a world once united. The scientific community was not ready. His ideas challenged the very foundation of what scientists believed about the Earth. They saw the Earth's crust as static, and the idea of moving continents seemed absurd. Many dismissed his theory outright, unable to imagine such a dynamic planet. Wegener faced ridicule and skepticism, but he was undeterred. He continued to defend his theory, convinced that the evidence was too strong to ignore. He dedicated his life to this idea, embarking on dangerous expeditions to find proof. He braved the harshest environments, risking his life in the pursuit of knowledge. He believed that, eventually, the evidence would speak for itself. Wegener's determination and curiosity pushed science forward, even when few believed in him. Wegener's vision would change our understanding of the planet forever. Today, we know he was right. The continents are still on the move, and the Earth is far more alive than anyone once imagined. Wegener called the ancient supercontinent Pangaea, meaning all Earth. This name captured the idea that, long before our familiar continents took shape, there was once a single, unified landmass. The concept was revolutionary, challenging the way people thought about the planet's history. Around 250 million years ago, every continent was fused together in this immense landmass. Pangaea stretched from pole to pole, dominating the surface of the planet and dramatically altering global climate, ocean currents, and the evolution of life. There was no Atlantic Ocean. India wasn't attached to Asia. Antarctica wasn't frozen at the pole. Instead, these regions were joined together, forming vast interior deserts and lush coastal forests, creating habitats unlike anything we see today. Imagine a world with one land, surrounded by one ocean. The endless shoreline of Pangaea was battered by a single enormous sea called Pangaea, and the interior was so vast that some areas rarely felt the influence of the ocean at all. Wegener reconstructed Pangaea, fitting continents together like puzzle pieces. He noticed how the shapes of South America and Africa seemed to match, and how other continents could be aligned to form a nearly perfect fit. North America nestled against Europe, South America against Africa and Antarctica, Australia, India, and Madagascar clustered near the southern pole. This arrangement wasn't just a coincidence, it was supported by geological and fossil evidence. This arrangement explained the shapes of coastlines and the distribution of ancient life. Fossils of the same plants and animals were found on continents now separated by vast oceans, revealing their shared past. Pangaea reminds us that Earth is dynamic, not static. Continents are always on the move, reshaping the face of the planet over millions of years. The maps we use are just snapshots in time. Millions of years ago, the world looked completely different. The continents we know today are just temporary arrangements in Earth's long story. The breakup of Pangaea was slow, unfolding over hundreds of millions of years. Powerful forces deep within the Earth gradually pulled the landmass apart, creating new oceans and mountain ranges. Cracks formed, magma welled up, and new ocean floor was created. These processes continue today, shaping the world beneath our feet. The Atlantic Ocean was born, pushing the Americas away from Europe and Africa. This slow drift continues, widening the ocean a little more each year. The continents are still drifting today at the speed your fingernails grow. Our planet's surface is always changing, and the story of Pangaea is a powerful reminder of Earth's restless spirit. The first clue to Wegener's revolutionary theory was surprisingly simple: the way the continents seemed to fit together, almost as if they were pieces of a giant jigsaw puzzle scattered across the globe. The eastern coast of South America and the western coast of Africa, in particular, appear to match up with remarkable precision, their coastlines curving and bending in ways that seem to echo each other across the Atlantic Ocean. This striking similarity wasn't just a coincidence. When scientists began to map the continental shelves, the submerged edges of the continents, the fit became even more precise, revealing hidden connections beneath the waves that made the match even more compelling. It was as if two pieces of a torn newspaper, separated for millions of years, could still be matched together perfectly, their jagged edges lining up to tell a story of ancient unity. This visual argument was both simple and powerful, easy for anyone to see, yet profound in its implications for the history of our planet. Of course, not everyone was convinced. Many skeptics dismissed the idea as mere coincidence or wishful thinking, arguing that the similarities were superficial and not enough to prove anything. But Wegener saw things differently. He reasoned that if two pottery shards fit together perfectly, it was logical to assume they were once part of the same vessel. The same logic he believed could be applied to the continents. In Wegener's mind, the Earth was like a broken pot, and the continents were its scattered shards, separated by time and the slow movement of geological forces. This simple but powerful observation became the cornerstone of his argument for a once-united supercontinent, which he called Pangaea, a world where all the continents were joined together long ago. Sometimes the biggest clues to our planet's past are hiding in plain sight, waiting for someone to notice their significance. Wegener's true insight was to take these clues seriously, daring to imagine a world very different from the one we see today. Wegener needed more than geography. He turned to fossils. Identical fossils of ancient plants and animals were found on continents now separated by oceans. The Mesosaurus, a freshwater reptile, was found only in South America and Africa, too small to cross an ocean. Other land reptiles, like Caenognathus and Lystrosaurus, had fossils scattered across continents that are now far apart. Glossopteris, a fern-like plant, left fossils on all southern continents, including Antarctica. The seeds were too heavy to travel across oceans. When plotted on a map of Pangaea, these fossils formed continuous belts across connected continents. The animals and plants hadn't crossed oceans, the continents had moved apart. The fossil record made sense only if the continents were once joined. Wegener's theory turned scattered clues into a coherent story. The rocks held the memory of a united world. Wegener also looked at the Earth's bones rocks and mountains. The Appalachian Mountains in North America matched the Caledonian Mountains in Europe. Same age, same rocks, same structure. When the Atlantic is closed in Pangaea, these ranges form a single, continuous belt. The Atlantic Ocean had split a giant mountain chain in two. Similar matches were found between rocks in Brazil and West Africa. These geological twins were once part of the same landmass. The odds of such matches happening by chance were astronomically low. The rocks told the story of Pangaea's creation and breakup. The evidence was written in stone. Wegener's final major clue came from ancient climates. Coal, formed from tropical plants, was found in Antarctica and Siberia, places now frozen. How could tropical forests have grown at the poles? In Pangaea, these regions were near the equator. Antarctica wasn't always frozen, it drifted to the pole over millions of years. Conversely, glacial scratches were found in today's tropics. When the continents are reassembled, these glaciated areas cluster around the ancient South Pole. The direction of glacial striations pointed outward from a central ice cap. The climate evidence told a consistent story. Continents had drifted across climate zones. The past climates made sense only if the continents had moved. Despite his evidence, Wegener's theory was rejected in his lifetime. Geologists dismissed him as an outsider and called his ideas fantasy. The main problem: he couldn't explain how continents moved. Wegener suggested Earth's rotation, but it wasn't enough. Critics clung to old theories, even if they didn't fit the facts. Wegener died in 1930, searching for more proof in Greenland. He never saw his ideas accepted. Decades later, new technology revealed mid-ocean ridges and magnetic stripes on the sea floor. This led to the theory of plate tectonics, the missing mechanism. Today, plate tectonics is the foundation of geology. Wegener is celebrated as its visionary founder. His story shows that science advances when we dare to see the world differently. Sometimes the truth takes time to find its place.